Okay, good morning, everyone.
Good morning, sir.
Morning, sir.
Good morning, sir.
Morning. Hope you are everyone good.
Yes, sir.
Good morning, sir.
So last 9 days we covered initial sessions, right? Now our foundation is clear about the networking and security concept, right? Then we started with the SIEM, why SIEM is required. Yes or no? We understand that at the time of attack, it is very difficult to look, to log in on the devices, to look and each and every logs, right? We understand that each and every device is recording the activities in the form of logs. Log is nothing but the record, right? We can log in the device, check the logs, and we can understand what activity happened on those devices, right? So at the time of attack, right, when there is a zero-day attack, right, those devices might not be able to take the action their own because they're not aware that particular connection is suspicious. In that case, for investigation perspective, we might have to look at the logs, but it will be very difficult at the time of attack if you're checking each and every devices, checking the logs, analyzing the log. It's very difficult. It's time-taking procedure, right? So we understand the requirement of the SIEM. We had two objectives. One is to collect the real-time logs from network device, security device, servers, application, etc. And once it collect the log, it normalize the logs. It make it readable format, common format. Yes or no? And keep the logs for a long time, searching and reporting. That means 1 year, 2 year, 3 year, 5 years. For a long time, you can keep the logs on your SIEM. Apart from that, it also has the feature of real-time monitoring, correlation, and alerting. That means instead of monitoring billions of logs ourselves, we can ask our SIEM to monitor on behalf of us in the form of correlation rule, right? Condition along with the aggregation, how many event in how much time, and what action has to be taken. Real-time monitoring, correlation, and alerting. When the condition matches, it will trigger an alert, right? So these are the two objectives that you'll have achieved from any SIEM tool, right? So now we'll start with the one of the tool Arcsight, right? Then after finishing it, we'll proceed toward the Splunk, right? So now almost it will take 1.5 months, almost 1 month, 1 month, few weeks, 1 to 2 weeks maximum. Why? Because first time we're understanding SIEM, right? Splunk will take another 1 month, and almost 2 weeks we have taken for this training has been designed for almost 3 weeks, 3 months, right? So 2 weeks we have taken for networking and security concept, right? Architecture and everything. Around almost 1.5 months max for Arcsight. Why it is Arcsight? We're taking more time Splunk one month because first time we'll be understanding SIEM, right? So many activities which are common on both the SIEM, right? Which is common like investigation, analysis, incident response. So any SIEM tool that you use, those activities are common. But when you understand first time, so we'll cover it in case of Arcsight. Once your concept is clear, those activities will not have to cover on Splunk, or you'll understand fast because you have already understood first time, right? So around 1.5 months for Arcsight and 1 more month for Splunk. Get it fine? So once we start the practical session, recording will be also shared so that you can revise and do the practicals, right? But today onwards, you have to ensure that you write the note, even though I will ask you to write, right? As well as just now, if people have joined late, I have just shared the SIEM notes document. Where you find the SIEM, whatever I'm going to explain you, I'm going to ask you to write, right? Same thing you'll find on the SIEM SIEM notes document that I have just now shared, right? Initial, these theoretical session will not be recorded. That means will not be shared. So you have to make sure that you join live. In case for any unfortunate situation, if you are not able to join, then you have to inform me personally prior to the class so that I will share you temporary one-time watch recording. Understand? I already explained you the reason behind not sharing each and every day's recording, right? Otherwise, if I would have shared the recording, half of the viewer might not have been here, right? Because 70% people even comes through references only, right? If I would have shared the recording, your brother, your sister, your the sister-in-law, your brother-in-law would have watched the recording to whom you are going to refer, right? That is the limitation. I'm here to support you, but I have to support myself also. That's the only bread and butter for our family, right? So that is the reason of not sharing the recording. But in case of any unfortunate situation, you can inform me personally so that I will share your temporary link to you so that you can watch and continue the next session. Okay, so let's start with Arcsight now.
Yes, yeah.
Sir, before we start, can I ask a quick question?
Yes.
This is the first session for me. Is it mandatory to go through all the recordings? Because I've enrolled just yesterday and I couldn't go
What's
through
your
all.
name?
I'm Swati.
Swati. Okay. So, see, you joined today's class, right?
Mhm.
So you did not watch any of the previous classes?
I watched 1.5 video, the initial classes, the first
Initial
and
class. Okay. So I'll recommend you to watch last 2 classes, right? So that you'll have a better understanding of further topics. Then you'll have, see, 2 hours class we are taking every day, right? Then you have whole day, maybe in couple of days you can cover those sessions also. But you will not face any problem further. Within a week you watch those, and if any issues, you reach out to me personally, because since you joined late. So
Today, would I be able to understand the
ping me.
session?
Yeah, let's see. You should be able to understand. Just cover those sessions in couple of days. Those are one time watch session. One time you watch it means around 12 hours, 14 hour session, right? So 18 hours, I think. First day just introduction, around 16 hours session that you have to watch. But those are just basics, initial session. If you have already some background of IT, you can come up here directly. But we'll recommend you to watch the miss session. Okay. So So Arcsight is one of the SIM tool, right? It is started in 2000 actually. It is started in 2000. It was one of the oldest tool and was the leader in the market for currently 13 years. In the market, as per the Gartner report, it was the leader for concurrently 13 years, right? No other competitor nearby, right? So it is started in 2000, one of the oldest tool, right? And it was, tool name was Arcsight and company name was also Arcsight. Like a Splunk, tool name is Splunk and company is also Splunk. Get I mean? And tool name is also Splunk. Similarly, Arcsight also started in 2000. Tool name is Arcsight and company name was also Arcsight, right? In 2010, it was acquired by HP company, and after acquiring HP, people started calling, and tool name has become HP Arcsight. HP Arcsight. Okay, in 2010. In 2016, HP has given this tool to Micro Focus. Now, in 2016 onwards, it has become Micro Focus Arcsight. What it has become? Micro Focus Arcsight, right? But in 2022, the Micro Focus itself has been bought by OpenText. The company itself, Micro Focus had some other product also. There are so many products apart from Arcsight. They have so many products. They had so many other products, but the company itself has been bought by OpenText in 2022. So now Arcsight is OpenText Arcsight. But many of the people are not aware. They still call them Micro Focus Arcsight or HP Arcsight. Right, but in 2000, at a certain time, migration is not happened completely. So still in documentation, you will see Micro Focus Arcsight. In an older document, you will see HP Arcsight. Get a point? So now,
OpenText is a company or
a company name. OpenText is a company name. Okay, you can search in the Google. You'll get that detail. OpenText is a company name, and Micro Focus now has been acquired by OpenText. Okay, so Arcsight also now OpenText Arcsight. Now, what we'll do is we will understand how we can achieve these 2 objectives using Arcsight tool. One is to collect the real-time logs for all network device, security device, etc. Collect the log and normalize the logs, keep the log for a long time and searching and reporting, as well as real-time monitoring, correlation, alerting. These 2 main objectives will understand how we can achieve using the Arcsight. Then after 1.5 months, we'll understand how we can achieve this objective using the Splunk. Get it? Apart from these two tools, Splunk and Arcsight, we have one batch for vulnerability management, Nessus vulnerability management. That is a separate batch. But what we have done, because it's good to have knowledge on vulnerability management, also vulnerability assessment, right? To find out the vulnerability assessment. So what we have given is we'll be giving access to the recorded session for Nessus vulnerability management, so that you can also learn vulnerability assessment as well, right? So so let's understand how we can achieve. So you know what happens, these SIEM tools are enterprise level of tools, right? So what happens is this is not a one device, it's not a single device that you can achieve all the objective, right? So these devices are enterprise level, so they have distributed architecture. That means they have multiple components to to achieve this objective. Different component does the different work. Get it? So Arcsight is having three main components, right? Let's understand what are those components. So architecture of Arcsight, right? One of the architecture. But the component for all both there are two architecture. So, but component on both the architecture will remain same. So let's understand what are the different components. Connectors C1, C2, C3. Okay. Logger and ESM. Okay. So there are three main component. Let me write some name here. A network device, router, Windows, switch, firewall. I have written few devices, but all your network device, security device, server, application, right? Whatever available on typical IT infrastructure, right? Written this, drawn, right? This architecture. So in Arcsight, there are three main components, right? One is connector, right? So here you can see multiple connector inside one server. There are multiple connectors, logger, and ESM, right? These are the three main component of of Arcsight, right? So so what do you understand? You understand, right? In this architecture, what do you understand? What connector is doing here? What it looks like?
Connect the all devices from
The agent which
network.
will be installed.
Connecting
Right.
the network.
Right. So connector is a component of Arcsight which is responsible. I will ask you to write, but first you understand, okay? So connector, you can see the component of Arcsight which collect the real-time logs from network device, security device, server, the application, etc. Once it collect the logs, it normalize the logs. Get in mind? Once it collect the logs, it normalize means make it unreadable to readable format logs. Yes or no? Mapping of device specific logs with the your SIEM defined common format log, right? Because we understand every device is having different format, right? So once connector will collect the log, it will make the log in the common format. Get in mind? Once we discuss the architecture, I will tell you the exact meaning of normalization on the SIEM, right? As of now, we understand different logs will be on the same format, common format, that we call as normalization, right? converting the unreadable logs to the readable, easily readable format we call as normalization. So connector, once connector collect the logs, it normalize the logs, right? And send the logs to the logger. Yeah, once it collect the logs, it normalize the log and send it to the logger. Get mind? And logger, you can see, as you can see it here. You have different connector, right? So you know what happens is, let's understand before that what is normalization. What's normalization? Let's understand. In what happens is, you have, for example, you have this kind of network, right? Last time you understand, on which you have a router on the gateway, right? And then you may have so many other devices. So you have switch, then Windows, right? So you have taken the internet connection, right? Then some other device, right? So behind that you have firewall. Okay, so any connection coming in, for example, it will hit to the router. Router will record what is source IP, what is destination IP, right? So then it will hit to the firewall, then it will switch, then it will Windows, right? So source IP is the IP address from which the connection is coming in, and destination IP address is the IP address of the destination machine where the connection is going to, right? So these all devices will record the activities because connection is bypassing, is passing through these devices, right? So you can see all these devices will generate the logs. Yes or no? Understand? If you open the router logs, source IP, you can see source IP is the IP address. For example, this particular IP address 199.0.2.100, right? For example, and destination address is 197.0.2.20, right? For example, this is the destination IP address. The connection is coming from here to here. Source IP is this one, right? And destination IP is this one. So if you see router log, you can see this is source IP, this is destination. Firewall log is source IP, this is destination IP. Switch of source, destination, and also here it is destination and this is source. Yes or no? So all these devices in middle will record the activities. Yes or no? But you can see this will be source and this will be destination only, intermediate devices. But what happens is, when these devices record the activities, because these are from different vendors, different type of devices from different vendors, so they give the different field set. For example, when firewall record the activity, it gives the source IP name as SRC. For example, SRC is 199.0.2.100. It is actually source IP, but the name is given as SRC. Since router is giving name source. See, it is actually source IP, but different device given different name. Yes or no? For example, your Windows giving the name. Windows device giving the name source IP. It is giving source IP, right? And your switch giving the name. Switch is not giving the name. It is giving just IP address without name. You can see just IP address 119.0.2.100. It is just giving the IP address. It is not giving the name. Get your mind? Understand? So you understand, if all these logs, when these logs will go on your SIEM tool, if you want to search the router logs from particular source IP address, you have to give the query SRC is equal to this one. If you want to search firewall, then you have to go source equal to this one. For this one, source IP equal to this one. Means these all are, this is source IP only, but every device is giving different name. It is very difficult to search, right? You have different, just for example, you have different other devices as well. But every device, if give a different field name, it is difficult to remember. For example, you want to search firewall log, but you are not sure now. Firewall gives the name source IP, source address, or source, or some other name. But that is not only source. Sometimes you have to destination also, device also. There's so many other fields. Every device will record the logs almost in 30 to 35 field set. Source IP, one of the field. Source IP, destination IP, source port, destination port, byte in, byte out, device. There are so many other fields. If every device will record the activity in different field set, you will not be able to remember. and then searching will be very, very difficult. Yes or no? Yes or no? Then compliance says that it is not going to work. But yeah, whenever you receive the log in the SIM, it should be on common format. Means this source address, source IP, SRC is not going to work. Whenever you receive the log on your SIM, that should be on common format. These all source related field should be identified with same name. So what your SIM will be doing is, for example, in Arcsight, every SIM will do the normalization, but here SRC source IP will be mapped with field source address. Source address. Now, when you search source address equal to this one, you'll get router logs also, firewall logs also, here, switch logs all. Because all SRC will be mapped with source address, source will be mapped with source address, source will be mapped with source address. Yes or no? Understand? So once you will see the field in Arcsight source address. So that is a common format logs, common format field, right? Source address. Now once you receive the logs on connector will map device specific fields about SRC. Okay, let him map this source address. Okay, is source for particular device, let him map with this source address. Yes or no? So you will see the logs on your SIM will be in common format, not different device specific format, right? That process is called as normalization, right? It's like DST, destination IP will be mapped with destination address. Similarly, there are 300 plus fields at an Arcsight. So Arcsight will identify what field is being captured by particular device, and it will map. Once it comes on the connector, it will map with your SIM defined common field set, right? So Arcsight is having 300 plus field set. So respective field set will be mapped with matching field. It's not happen that, okay, source is mapped with destination address. No, matching field set, so that you can understand yourself. You understand? Source means the connection, the IP address of a particular system from where the connection is being originated. The source actually reveals it's a source address, source IP address, right? The source cannot be mapped with the destination. So Arcsight will identify and map particular field with the matching field set. Like for example, action will map with device action. Yes or no? Understand? DST port will be mapped with destination port. So matching field set, you're going to easily understand. Now in this field, you may not understand and it would be difficult sometime, but once it will map with Arcsight defined common field set, you can easily understand. So Arcsight is having around 300 such field set. So whenever any logs are coming, it will identify and map it. So Arcsight gives the name, for example, source address, destination address, source port, destination port, device action, this kind of common field set. While if you call in Splunk is also having common field set, right? But field set name is different. Like source underscore IP, destination underscore IP means it should be common field set only, but name any SIM vendor can give their own. But all the logs once you come on the SIM should be on common format. Understand? Clear? This is called as normalization. Normalization is nothing but the mapping of device specific field set with your SIM defined common field set is called as normalization. Understand? That is the reason you can see in a connector you have C1, C2, C3 means connector 1, connector 2, connector 3. You understand? Why we have different connectors? Because one connector may not understand the different field from different device and match it. Because what happens is, for example, this connector, because connector Arcsight has defined, for example, this is Windows connector. Then Windows field set will map with your Arcsight field set. For syslog router connector, for example, router field set will map with the Arcsight field set. So different devices are having different field set. So one connector may not understand different devices field set. Yes or no? That's the reason for different devices we have different connectors. Understand? Because one connector may not understand the field set of different devices. That is the reason for different devices you may have different connector. For example, this is a Windows connector. It's not something that you can integrate only one day, because if Windows device connector can understand the log from any Windows device, one connector you can integrate multiple same kind of device. For example, a Cisco firewall connector. So multiple Cisco firewall can be integrated. with the same connector. But if your checkpoint firewall having different field, this connector may not understand. In that case, you might have to install checkpoint firewall. Get a mind? Understand what I'm saying? Clear? This normalization. But before the normalization, one more task happens that we call as parsing. That will call as parsing. Let me tell you what is parsing. But in Arcsight, within the connector only, I'll ask you to write the definition for both parsing and normalization. You can write. So let me tell you what is parsing. In Arcsight, when we talk about the tool Arcsight, some people refer parsing only for parsing and normalization both, and some people refer normalization for both parsing and normalization, because parsing and normalization happen on the same place on the connector itself. That's the reason collecting the logs, parsing and normalization happen on the same place. But in a Splunk, parsing and normalization happen on different places, right? So let's understand what is parsing. So you know what happens, for example, in firewall log, everybody is on the same page, right? Understand? Any confusion so far? अच्छा तुम पानी उससे नहीं लेके आया आज, चलो वाटर कूलर ठंडा आता है उस पानी. हाँ, yes, go ahead.
Sir, here is the connector for the different device, right? System for the different router for the different.
As of now, you understand. We'll deep dive on this. For which device, which connector we have to install. Get it?
Sir, as the devices increases, we have to increase the connectors, right?
Right. We'll deep down. We'll deep down. Same connector, for example, one connector, we have Windows connector. You can integrate 100 of devices with the same connector, right? What are the dependency, resource, and everything we are going to deep down. Just I am giving the brief understanding. We'll deep down which connector we have to install and how many devices we can install the same connector. Whenever you have any devices, which connector you have to install, everything we are going to do deep down on this. Okay. So let's understand the parsing first, right? So you know what, for example, firewall logs, firewall. Once you log in on the firewall, you will see the log file, one file inside on which notepad kind of file, right? Where the logs are being recorded, right? In this file, you will see, for example, time means at what time the log has been recorded, means activity happen. For example, 10:26, right? Then SRC is equal to some IP, DST is equal to some IP, right? Xon, right? For example, one log, one event start from here to here, completed. Then other event starting from here to here. Another event here to here. Then other event here to here. Other event here to here. Means there is no proper breakdown. If you want to read this logs, you can see one log starting from here to here and finishing, for example, here. Another log is starting from here to here, finishing here. Another log here to here, finishing here. It's kind of mess, right? It's difficult to, difficult to analyze. Yes or no? Because there is no proper formatting. There is no proper formatting. One log field time here, but other log time is starting from here. Other log time is starting from here. There is no proper breakdown. This log we call a raw logs. On the device specific format and how they record these logs we call as raw logs. When any device record the logs, those logs are raw logs, raw vegetable, right? If you want to eat, then you cannot eat raw vegetable, right? You have to mix and make a curry, right? Meaningful things, then only you can eat, right? Similarly, these logs we call as raw logs, right? To make it more readable, what you can do, if my logs are like this, if my logs are like this, SRC is equal to 10.0.0.2, DST is equal to 199.0.2.100, Xon is equal to allow. For example, I have written only 3 field set, but there will be multiple field set. For example, this is one field set, one event. Now 2 event, second event, for example, one event, second event, SRC is equal to 192.168.0.2. DST is equal to 197.0.2.100 action is equal to deny. So you can see it here. If logs are coming like this format, right? It is better, right? Now you can identify proper breakdown of the logs into the columns, multiple columns. You can see one is log here to here, and you can see proper source, DST, and you can see proper format. Yes or no? You can see one thing here, field is not being changed. In firewall, it required SRC, then it is SRC only. Field has not been changed, right? But it has been formatted in columns. Proper breakdown in the log in the column. Break down the log field set, raw log field set in the proper columns, right? These logs we call as parse logs, and this process called as parsing. Parsing means proper formatting, proper format, proper breakdown the logs into the columns, right? These logs we call as parse logs. In parsing, it does not change the field name. Just it format in the proper format, in the sense properly break down the event into the columns so that you have better visibility. Yes or no? Understand? It was a mess previously, starting from here to here, here to here, here to here. There is no proper format columns. But now we have proper columns, proper breakdown of the field. This is called, these are parsed logs. What? Parsed. These are parsed logs. And this process called as parsing. Making this like this, we call as parsing. So parsing is nothing but the breaking down the event into the columns, different columns. Breaking down the raw logs into the different columns, we call as parsing. After parsing, now in parsing, the same field set, devices field set. Now this field set will change to source address, for example, common format. Source address, this is destination address, this is device action. Means your SIM defined field set. This process called as normalization. Changing the device, mapping the device specific field set with SIM defined common field set is called as normalization. So first parsing will happen. After that, it will normalize. Right? So both the process are happening on the connector itself. In the connector, once the log will connect to the connector, first of all, it will pass the event, right? After that, it will normalize. So in this connector, one file we call as parser file. In the connector, which is developed by Arcsight, one file will be there inside that. That file we call as parser file. Parser file, right? On which Arcsight had defined which field of particular, for example, this is Windows device, right? And this connector is Windows. So Arcsight will understand, first of all, before when Arcsight will design the connector, right? It has to upload the parser file so that Windows related field set should be mapped with the Arcsight related field set. So when the first time Arcsight may have created the connector, it will look on the logs, what field is being recorded in the Windows. Then it will map particular Windows field set with Arcsight defined common field set. Yes or no? And those mapping will be defined on the parser file. Which field of Windows will be mapped with which field of Arcsight. So parser files are different for different type of devices. That is the reason we have different connector for different devices. Understand? So those normalized field set, which is the Arcsight common field set, we call as CEF. What we call as CEF means common event format. So Arcsight is having 300 plus field set. 300 plus field set. So it defines a parser file which field set has to be met with which field of Arcsight, which is a part of CEF. Such 300 plus such common field set is having. So particular device specific field set will be mapped with matching field set of CEF, Arcsight common format. Understand? First of all, let's write what is connector. Then we'll write the normalization process, right? So you understand? You remember this, right? This architecture, the three main component of connectors. The three main component of Arcsight, connectors, logger, and ESM.
Sir, what did you say? Can you just repeat once?
What I said, there are three component, right? ESM I have not explained yet. Logger and ESM work as I have not explained yet. Okay, so there are three component, right? Connectors, logger, and ESM in this architecture. So what is connector, right? So you write connector hyphen. Connector is the component of Arcsight. Connector is the component of Arcsight.
Sir, can we say the first component of the Arcsight?
No, we should not use our own words, but you just write connector. Okay, so connector is the component of Arcsight. Which collects the real-time logs, which collects the real-time logs from network devices, security devices, network device, security devices. ये हो गया क्या यार? Servers, network device, security device, servers, etc. Sorry, 1 minute. Network device, security devices, servers, application, databases, etc.
Applications.
Databases, etc. Once it collects the logs, 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 once it collects the, it normalizes the logs. अरे ये क्यों आ रहा है यार? It says another meeting in progress. You guys did not inform me. Some people are not able to join. I did not see them.
So once it's collect the logs, then
1 minute, huh? Some people are not able to join today.
But I think they were outside of India.
1 minute. One minute.
But why it did not work? Post another meeting was. Acha. They actually, it seems, they had joined previous with the link. They had to register and join from this link, which they got just now today in the class. But I think they are trying with the old link, which was shared last week. That is the reason. Other meetings in progress, of course, they should join. So what you have written? What you have written?
So once it collects the logs.
Once it collects the log, it normalizes the logs. Sorry, once it collects the log, it passes the logs. Once it collects the logs, once it collects the logs, it passes the logs. P-A-R-S-E. Once it collects, it passes the logs, normalize the logs, normalize the logs.
Now after parse the log, normalize the log, right?
Once it passes the log, normalize the logs. Once it collects the logs, it normalizes the logs. Filter out the logs. Filter out. I will tell you what is filter out. Once it collects the logs, it normalizes the logs. Filter out the logs.
So parse the log and normalize the log both are same, right?
Just now I explained. Parsing and normalization both different, right? I just explained 5 minutes back. You're asking again. You're not in the class.
Not sir. You are saying once it connect the logs, parse the log, then normalize the log.
Yes. So I have explained you right what is parsing and normalization. Just 5 minutes back.
Okay.
Okay means you did not fake us. What you are doing? Clearly, I had explained what is parsing and what is normalization. So once it collects the logs, it passes the logs, normalize the logs, filter out the logs, and send it to destination, and send it to destinations, and send it to destinations such as logger and ESM. Send it to destination such as logger and ESM.
So I have a question. So I believe that during parsing, the fields does not change.
Right.
But during normalization, does the fields change?
Right. That is what normalization mapping of device specific field set with your SIEM defined common field set. It will map, right? And field name will get changed the common field set name, right? That is called normalization. You'll write normalization also. So in definition, you have written once it collects the log, parse the logs, you understand parsing. We'll write also. It normalizes the logs, you understand normalization, right? It filter out the logs, right? Filter out means, sometimes in your connector, some logs will come which are not required. See, SIM means security, information, and event management, right? Some logs may be non-security logs, which are not required on your ESML logger, because your SIM, all the SIM license will come based on the number of events which are receiving per day. In more and more event, more and more license utilization. Generally, connector or collecting the agent which are collecting the logs, they will not use the license. In Arcsight connector also, as many logs you receive, as many connector you can install, does not require separate license. There is not required paid license. But as many as
So your voice breakdown in between.
What I'm saying is, I will connect to the mic actually. Since 4 days I did not charge mic, I was not aware that it has been discharged. So I just plug in the mic. That's why I am not coming in the form of board right now for 2 minutes. It is in charge, it will get charged fast. So what I'm saying is, what I was saying, that some logs you see stand for security, information, and event management, right? That means security information, security event. Some of the logs which are being generated by the device may not be related to security. If unnecessarily those logs you collect and receive on the ESML logger, that means license usage, unnecessarily storage usage, right? And there are some other situations which we will be understanding in the later part, that in that case, you need to avoid those logs. So you have the option on the connector to put which kind of logs you want to send and which kind of log you want to drop off. So if you apply the filter means filtering, right? You understand T filter? Unnecessarily things will not go inside, you will not be able to drink. Yes or no? So similarly, you have the option of filtering on the connector. So you can drop off unnecessarily event on the connector level before sending it to the logger and ESM. Here in this architecture, connector is sending the logs to the logger and the logger further to ESM. But we will have another architecture that we call a dual destination. I'll be explaining you, on which your connector can send the log parallelly to the ESM also and logger also. That's the reason on the definition you have written, connector collect the logs and send the logs to the destination such as ESM and logger. You have not written ESM and logger, but you have written such as. Why such as? Because it may also send the logs to any third-party SIM tool, third-party intermediate server. Connector has the capability to forward at the same time. If you want connector logs to be forwarded to Splunk, QRadar, some cloud, you have multiple options here. That's the reason you have written the definition. Once it collects the logs, it will send the logs to the destination such as ESM and logger. Such as means some other destination is also possible. In Arcsight architecture, there will be 2 destinations. But if you want to forward your logs to some other destination also, you have option. Understand? So you have written on the definition, connector is a component of Arcsight which collect the logs from all these network device, security device, server, application, etc. Once it collects the logs, it parse the logs, normalize the logs, filter out the logs, and send it to the destination such as ESM and log. Clear this, right? Completely clear? Let me check my mic now.
Yes, sir.
Let me go just hold down. Let me check my mic status. So it will connect and come on the board. The charge very fast. So let me check how much charged. 50%.
I'm audible right now?
Yes, sir.
Okay.
Yes.
So
what is the
now what is normalization? Now you write what is like normalization hyphen. You write normalization. No, sorry, 1 minute. First write parsing, then normalization. Parsing.
Sir, can you pronounce?
Parsing. 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 We use the word parse sometime. Parse. Right? And process called parsing, right? So it is the process of parsing. It is the process of breaking down the raw logs, breaking down the raw logs into the separate columns. Into the separate columns. Into the separate columns. Written? I'll quickly show you something. Let me check whether. I'll quickly show you something. How raw logs look like and how parse log look like. Okay. So quickly, I'm just showing my screen. I'm showing it in a Splunk. You can see the console, my screen, right? Everybody?
Yes, sir.
Yes, sir.
Because in Arcsight, once the logs come right, it normalize, right? It bars and normalize. So in the so I'll tell you. So in the Splunk, let me show you the Splunk how the logs look like. In Arcsight, we can see the parse logs and normalize the logs, but we cannot see the raw logs. No, raw logs we can see, but parse log we cannot see. Directly normalization we'll see, right? So in a Splunk, you can see raw logs also, parse logs also, and normalized log also in the Splunk. So I'm showing in a Splunk right now. But in Arcsight, while you collect the logs, at that time it will parse and normalize both the things. But in the Splunk, it collect, parse, without normalization, it store the logs. In a Splunk, normalization happens during the search time. When you're searching the logs, there is a specific component required to normalize the logs. So right now, the logs that we will see are not normalized logs, are just a parse logs, right? So when I search the log here, for example, so I'm just quickly showing you so that you'll have little idea. But anyways, we are going to do all these practicals. Just you can see this. You are seeing my screen, right? You are seeing my screen. You can see.
Yes, sir.
These logs are raw logs. How Windows recorded the log, same format. Same format. You can see same format these logs are. The same as raw. Same as how Windows device has its Windows logs. How it records the log. You can see this identifier equal this one, event code equal this one. These are the same Windows logs. Is raw logs, right? Not proper formatting. You can see proper breakdown is not happening. Not proper formatting. You can see something is written like this. Not proper formatting, right? But parse logs, if you want to see the parse log, you can see proper formatting. When I click on the arrow, I can see this parse log. You can see proper breakdown here. Not always the column that I have written, but you can see it's individual. Okay. Individual, you can see proper. Yes, this one equal to proper. You can see proper, understand easily. Proper mapping every day. You can see this big data. It was mapped under. It was under the message only, but in the raw log, it was not clearly. There's so many mashed up, right? But here you can see properly mapping, properly parsing, breakdown happen properly. Clear mind? Understand? So this is what we call as parse logs, right? So in case of normalization, this field name, the account name, username captured under account name. Get mind? Account name. But in case of Linux, username may capture under user field, different. But in case of once it normalize, the account name will change with the username. Get in mind? For all the devices, that will cause normalization. Means in case of normalization, field name will get changed. Understand? As of now, these are device specific field set. In case of Windows, it captures under account name. In case of Linux, it may capture under user. In case of firewall, it may capture some other. In case of, for example, some other proxy, it may capture some other name. Yes or no? Username. So field name will get changed in case of normalization. Okay. So what you have written? Parsing definition you have written, right? What you have written in parsing, Sachin?
It is the process
The
of breaking
process
down
of
the notebooks.
Separate column.
Understand, right?
Separate
Here,
column.
everybody understand parsing, right? Now write
yes,
normalization.
sir.
Normalization. Normalization.
So
So,
parser file and all.
what?
Parser file.
What you're telling? I'm
Yes.
not.
So you said about parser file also. Will you give notes on that?
Parser file is nothing but see, parser file means the name is parser file, but actually it help your connector to break down the event as well as it define the normalization setting also. Means mapping of device specific field set with the SIM defined common field, yeah, Arcsight defined common field set that we use in Arcsight, right? That is called parser file, which is there on the inside all the connector. Correct? Parser file define the parsing as well as mapping of device specific field set with the Arcsight defined common field set. Here in case of Arcsight, that file is called parser file. Get it? So, so now you write normalization. Normalization. One moment. Normalization. So normalization is nothing but the mapping of. Normalization is nothing but the mapping of. Normalization is nothing but the mapping of device specific field set, specific field sets. Normalization is nothing but the mapping of device specific field sets with the SIM defined common field set. With the SIM defined common field sets. With this SIM defined common field set. In case of Arcsight, common field set name is CEF. CEF, common event format. In case of Arcsight, common field set name is CEF, means common event format. Common field set name is CEF, that means common event format.
Sorry, in case of Arcsight,
Common field set name is CEF. CEF means common event format. In case of Arcsight, common field set name is CEF. That means common event format, right? In case of Arcsight, that common means Arcsight is having their own 300 plus field set, right? It will map the data in those field set, right? In case of Arcsight, those field set we call a CEF. In case of Splunk, Splunk is having also their own field set. In case of Splunk, those common field set we call a CIM, means common information model. In case of Sentinel, we call a CEF again, common event format. In case of McAfee SIEM, we call a CEF again, common event format, right? But field name is different. Compliance says that, okay, the field name should not be different. Whenever you're creating the logs, field name should be on common format. But compliance does not say that, okay, you have to use these field set only. Any SIEM vendor is free to use their own name, own field set, right? But all the logs should be on common format, right? That is called as normalization. So understand the use of connect. What is the use of connector? Collect the log, normalize the log, pass the log, filter out the log, send it to the destination, such as logger and ESM. Now let's understand about the logger. Understand first, then you'll write. So logger is the component of Arcsight which collect the logs from connector, right? Once it collect the logs, right, it keep the logs for long time. Mean it store the log for long time, 1 year, 2 year, 3 year, 5 years, based on your company requirement, right? Security requirement, forensics and audit requirement, compliance requirement. It can keep the log for long time and enables you searching and reporting. That means whenever you want to search the logs, you can log in the logger and search the logs. Yes or no? Log in on the logger and search the log and download the logs in the such as CSV or PDF format. Get it? So what happens is, once you install the logger, right, you can access the logger console using web browser. For example, in this server, you have installed the logger, for example, 199.0.2.100. This is the IP address of the logger device on which you have installed, right? Then you can open the web browser and you can type https://199.0.2.100, right? This URL you can type, enter the username and password. You can see the logger console. In logger console will be search bar where you can write the query and select the time for which you want to see the logs. Get it? Search and you can see the logs and you have the option to download the logs also. Yes or no? So once you select the time, you can download the logs, right? So you understand? So logger work is to collect the logs from the connector. Connector is required, right? Connector only respond. You can't directly logger or directly in the ESM. You need connectors, right? So connector collect the logs from your logger collect the logs from connectors. Once it collect the logs, it keep the log for a long time, right? Based on a company requirement, security requirement, audit and compliance requirement, forensic requirement, right? And enables you searching or reporting feature. That means we can give the query, we can see the logs on the logger console, and we can download on the CSV or PDF format. Understand? Let's write what is logger. Logger hyphen.
Sir, I have a question. So for whatever the logger we install on the device, so it has particular port number also?
Yes. We'll understand. That also port protocol, that also will understand. So this logger, anyways, port number, everything I will explain you. So you write logger is the component of Arcsight. Logger is the component of Arcsight. Logger is the component of Arcsight which collect the logs from connectors. Which collect the logs from connectors. Which collect the logs from connectors. which collect the logs on the connector, which collect the logs from the connectors. Once it collect the logs, once it collect the logs, once it collect the logs, it keeps the log for long time. It keeps the logs for long time. It keeps the log for long time based on organization requirement, based on organization requirement. Security requirement, security requirement, audit compliance, audit compliance, audit compliance, and forensics requirement, audit compliance and forensics requirement. Just give me a moment, okay? I'm just coming. So Rita, right? Audit compliance and forensics requirement, right? A minute, I'll fix the camera. कैमरे का एक केबल थोड़ा लूज हो गया है, चेंज करना पड़ेगा. हाँ, so you written right, audit compliance and forensic requirement, right? Get it? And it enables you searching and reporting feature, and it enables you searching and reporting feature, and it enables you searching and reporting feature. That means in bracket you write, that means we can write the search query on the logger. That means we can write the search queries on the logger. Analyze the logs on the logger console. Analyze the logs on the logger console. Analyze the logs on the logger console. That means we can write the query on the logger see, analyze the log on the logger console. Analyze the logs on the logger console. And download the logs on the CSV and PDF format. And download the logs on the CSV and PDF format.
Can you repeat, sir?
And download the logs on the CSV and PDF format. And download the logs on the CSV and PDF format. Right? Clear?
Sir, whereas in Splunk, it collects raw logs as well, right? In the logger.
In Splunk, it is searchable. In Arcsight, you can only search the logs using normalized field set. For example, you have the logs coming in, some field having SRC, source address, right? But while you have logs in the logger and ESM, you can only search using common fields such as source address, destination address. You can't search like SRC is equal to this one, DST is equal to, you can't search. You can only search using the normalized field set. Get in mind? However, in this Splunk, because Splunk is one of the data analytics tools also that I'll be explaining you later part, not only SIEM tool. So it have more functionality. Only SIEM tool will search only normalized event, but since Splunk is one of the data analytics tool also, raw logs also you can search on the Splunk. Raw logs, sparse log, normalized log, all logs are searchable on the Splunk, right? But in Arcsight, another SIEM tool like your QRadar, your logarithm, all only normalized logs are searchable. Right? You can see the parse logs, but you can't search. Whenever you are searching normalized logs, you can see the normalized log, but there is a plus icon. Once you click on plus icon, you can see respective raw logs. Get in mind? But you can't search the raw log fields while you search. But in Splunk, you can do that.
Okay? So I assume that the logger only houses normalized logs, correct?
Yes, means it has normalized logs as well as when connector forward the logs, right? It normalizes the log, but it send the parse logs also, raw logs also, raw log, but raw logs are not searchable. For example, when I search any logs which have the source address, 10.0.0.2. So it will search for let's say 10 minutes. Right? It will show you every logs which has the source address, destination address, and all those stuff. So once you see the normalized logs, below the normalized logs, there's a plus icon. By default, it will not show the raw logs, but there's a plus icon. The raw logs which are involved in this normalized logs, right? Once you see the plus icon, you can see the raw logs also, respective raw logs. The raw logs only parse and normalize, right? So your respective raw logs also you can see the below, but these raw logs will not be searchable. Directly, you can't make the query and search raw logs. You have to write this query only, which is based on normalized field. Understand?
So is there a possibility during configuration to take out the raw logs such that it doesn't occupy storage in the logger?
You have option. You have the option on the connector. If you don't want to forward the raw logs, then you can stop it. But sometimes raw logs are important. Some little fields may possible that any of the field may remain not normalized to the normalization, may left, not mapped properly. Then if you see that sometimes forensic perspective, you might require to see the raw logs as well. That's the reason in plus sign you can see the raw logs. But raw logs exactly how device has recorded the logs, right? But in case normalization field set has been changed, right? So sometime in forensics, you might need to see the raw logs. Understand? Okay, so now let's talk about the ESM logger. Understand what is the work of logger? Now let's talk about enable searching robot. You have not written. Logger is not completed definition, not completed. Logger definition is completed. So क्या पूछ रहे हो फिर तुम? अच्छा. So you understand, right? हाँ बता रहे थे. अच्छा sorry हाँ. You understand the working of logger, right? It collects the log from connector, keep the log for a long time, right? Based on what retention period you have defined, means how long you want to hold the logs, right? Based on forest requirement, you will keep it for a long time, and it enables searching and reporting. You can write the query, get the report, download the report in the various formats, right? Now an ESM, right? So understand first, ESM is a component of your Arcsight which collect the logs from connectors, right? And it enables you real-time monitoring, correlation, and alerting. Second feature, real-time monitoring. Once the event commit will monitor real-time, and once particular correlation rule matches, it will trigger an alert. So real-time monitoring, correlation, correlating the condition along with the aggregation, how many event in how much time. You understand, like last class? So that we will not have to monitor billions of log ourselves. Instead, we'll ask our SIEM to monitor on behalf of us. So in this Arcsight component, ESM does the same work, right? We can write certain correlation rule here, right? Once each and every log which is coming on the ESM will be monitored, and once the correlation condition matches, it will generate an alert, right? So real-time monitoring and correlation and alerting will be enabled by the ESM. Yes or no? So ESM is a component. ESM stand for. ESM stand for, anybody knows? ESM stand for
Security management.
Enterprise Security Manager, right? ESM stand for Enterprise Security Manager. Enterprise Security Manager. ESM stand for Enterprise Security Manager.
Sir, that correlation rules are predefined rules, sir?
No, some are predefined. Last time we understand also predefined, and some we need to create, and which are predefined also we have to modify, because every organization may have different requirement. So some rules are correlation rule coming out of the box on the SIEM, but you might have to modify. That means fine tune based on your requirement, and some of the rules you might have to write yourself. Customized rule that we call as. Okay. So you write ESM stand for Enterprise Security Manager. Enterprise Security Manager. Enterprise Security Manager. It is the component of Arcsight. It is the component of Arcsight It is the component of Arcsight which enables you for which enables you which enables real-time monitoring, which enables real-time monitoring, correlation, and alerting features. Which enables.
Please repeat again, sir.
It is the component of Arcsight which enables real-time monitoring, correlation, and alerting feature. Written? Written, everybody? So you understood, right? Feature, first objective. We have two objectives, right? On the SIEM, right? First objective almost we can achieve using logger. And second objective, real-time monitoring, correlation alerting, we achieve using the ESM. right? And collection of logs, normalization, parsing in the common format is being performed by the connector, right? So these three components perform different activities, right? That's the reason we call it Arcsight has the distributed architecture. This architecture is distributed because different component is performing the different activities. Understand? So as per this architecture, your connector collecting the log, forwarding the log to logger, and logger is forwarding the log further to the ESM. That's the reason this architecture we call linear architecture of Arcsight. If you want, you can write on the top. This architecture is the linear architecture of Arcsight. This is the linear architecture of Arcsight. Linear architecture of Arcsight. Understand? Why we call linear? Because connector is forwarding logger further to ESM, the linear model, right? That's what we call a linear architecture of Arcsight. It is right. Understand? Written. Now, let's understand where we can install this component, whether hardware, software, right? Which model they are. Right? So let's start from connector where we can install, right? So connector is coming on hardware model, software models, hardware and software device both, right? But majority of time we use software. Get it? So what happens is your connectors, right? So for software, connector will be an agent, one software application that you can install on the server. Everybody is aware about server and workstation? Server?
Yes, sir.
Yes, sir. Yes.
So server, you are aware? You know server. What is server?
Yes, sir.
So I'm just asking so that on that case I can explain. So people, anybody who did not know what is server? What do you know? What is the difference between your workstation, means desktop, laptop, and server? Are you aware?
Sir.
Okay, because once you start working in the company, right, you'll see the word server, the application server is down, right? You see on website, the server is down currently. What is that server about? Which server is down? Yes, you heard this word, and you see this particular component device is installed on the server. This software is installed on the server, right? So what is the server? It is not your like your workstation that you have desktop, laptop, or how it is different from your workstation, desktop, laptop, right? You know what happens? Let's have a quick understanding. Little more understanding, not quick, little more understanding. Do you know what is operating system? What is the use of operating system? Achha, you tell me what is your, which operating system you have?
Windows 11.
Windows
11.
These are operating system. Why we call them operating system?
The system operates.
Sir, it is an interface between hardware components and the user.
Hardware and
Hardware components and the user.
this is the interface between the hardware and user.
User and machine.
User and hardware, right? So this is, you can see on the book. Same definition you gone through in the book. It is interface between the hardware, software, or hardware and user, right? It's an interface, right? But
made it up.
do we actually understand? Have you actually understood how it is, right? Let me tell you that. In, for example, you have some machines, right? For example, you have some physical machine, some physical motor you have, right? In physical motors, there are multiple component, hardware components, right? If you want to start motor, right? So either you you have a button, right? You click and motor will get installed and start, right? And you have different functionality to do this. You turn on this button or you do something by your hand. Yes or no? Because in this physically, there's a big motor. All the functionalities are physically present. You can see them and you can actually operate them. You can actually operate them, right? Manually in this motor, in this physical machine, right? So it's a big machine. Whatever feature you have, you can see them physically, right? So this is the hardware, right? Similarly, in computer, you can see in this motor or this machine, only some activities are happening. Like you can see in the mechanical production company, you'll have big machines, right? Big machines. You can actually see them how they are functioning. Yes or no? Physically see them how they are functioning, right? If you want to do some different function, you can change physically. But in your computer, you understand so many functions are happening. Yes sir. So many activities you can perform, but the machine is very small. Just you can see the processor, motherboard. You can see inside the computer. You can see motherboard. Inside it has PCB and all different capacitor and different like you have a processor, RAM and everything, right? So all the processor is happening here. Get it? Get it? So if in machine, if you want to do different activity, you can go and operate manually. But in this small hardware, if you want to copy paste, for example, some file copy and paste, can you open CPU unit? Okay, let me change from this to this to copy and paste. Let me transfer. Oh, I want to transfer file from here to here. Here to somewhere. Let me transfer from here to here. Can you do that? You cannot do that, right? Yes or no? This small chip motherboard that you have all the functionality inside can do a lot of work. You understand, right? But we cannot see them physically. We cannot operate them physically because we cannot see here physically. What? Because this small chip has a lot of functionality. We cannot see and operate them physically. Yes or no? Then to operate this and see which all feature we have operating system, right? So this is there on the hardware. This you can see in your, for example, your desktop, you have the CPU unit in desktop, right? On which inside you have motherboard, you have resources such as memory, CPU, hard disk, right? So here this forms the hardware machinery, right? Now in order to operate this hardware, we have operating system. In this operating system now, whatever the functionalities having this machine can perform, you can see those functionality on the operating system. You want to copy paste? Then once you do copy and paste command you perform, actually the command is being sent to your hardware and hardware will run that command. But since we cannot see this button here, we are doing it through operating system. Yes or no? So whatever we are doing actually is being run on the hardware. But since we cannot see those functions physically, that's the reason we have this operating system where we can see different functionality here. That I mean, once you click or whatever activity do, actually the activity is being performed on the hardware. So that is the reason you are here. That's the reason we call as operating system is an interface between user and hardware. It's an interface. Whatever functionality is having, we can perform using the operating system, right? So operating system now, since we have different vendors, like you have bikes, you have Bajaj, you have you have Honda, right? You have Entizer, you have Enfield. Yes or no? Functionality is same, bring you from source to destination only, but some accessories, some little different features. Yes or no? But your operating system cannot have any feature which your hardware doesn't support. Yes or no? If you add some different feature which hardware does not have functionality, you cannot do that. Yes or no? So what happens? See, there are different vendors, there are companies which have developed this operating system, like Microsoft. Microsoft that we have developed operating system that you can use to operate this hardware. Yes or no? So now you can install in this machine, you can install Microsoft Windows OS, right? Now there are different vendor. Linux also you have, and Linux also different vendors. Linux is again an operating system, right? Now instead of Windows, you can install Linux. What you can do activities using Windows, similar activity you can do the Linux. Just the feature is different, like way of doing mechanism may be different. Mostly Linux we use command line, directly we run the command. In the backend it is command only. Yes or no? The instructions are being sent to this motherboard, the processing unit, using the commands only. But in Windows desktop, you have some functionality, you can see that manually, and backend it will run through command. Similarly, Windows, you have different operating system such as Linux, right, Mac. These all are operating system which are actually going to operate this hardware. Get it, right? Now you can see workstation operating system as well as server operating system. Server we call if we have installed server operating system. If we have installed workstation such as your Windows 7, Windows 8, Windows 10, Windows 11, these are workstation operating system. And for example, Windows Server 2008, 2012, 2016, 19, 21, 23, these are server operating system. So what is the difference between Windows 10 and Server 2012, 2016, 2019 Windows? What is the difference? What happens is, generally, see, laptop, desktop hardware has been designed to use for personal use, daily office use or personal use, not to deploy any software or application which has to be accessed by number of users. Got it, mind? So if you want to deploy any software, it required more features. On the operating system, it required more features, while for normal use, it required less features. So if you deploy Windows 7, Windows 10, and if you deploy Windows 2012 server, the desktop and all will look like the same. But in server operating system, you will have more features which we can use to host any application. Get it, mind? But in desktop operating system, you have limited feature which are required for daily use, for your personal use, for company daily office perspective, but not to host the application, not to host any application, or to allow number of users to access it, right? So your server operating system will have more functionality compared to your workstation operating system. You will not believe, you may not be aware that in your laptop desktop also, instead of Windows 7, Windows 8 or 10, 11, you can also deploy, instead of that operating system, you can deploy server operating system also. Windows 2012, Windows 16, 19, or any server operating system also you can deploy, and you can see more functionality. But from desktop laptop perspective, not required, because if you deploy server, it has more feature and it will use more resources such as memory, CPU, and your disk. You want to use normal purpose, that's the reason you go for lightweight operating systems such as Windows 10, Windows 11, Windows 7, 8 and all. You understand? So operating system is nothing, so that we can perform the activities on the hardware that you call as operating system. Yes or no? How you do the activity. Your food is, you eat food, right? And you get the energy. Yes or no? Now, in order to run this machinery hardware, it also requires some resources which can use to perform the activities. The food for this hardware, computer hardware, is there are three things which gives the energy to this hardware that we call as resources, right? In this hardware in computer, there are three resources which makes your system fast, or which make your system to run, which are required to run your system, right? First is RAM, or in short we call it memory. In short, we call as memory. Second is CPU, or we call a processor. What we call as processor. And third is disk or storage. Disk or storage. Storage means disk. Storage means here you will have disk. Understand? Now, what is the use of RAM? You understand, right? If you have less, generally you go in the you want to buy the laptop. Some people are not aware. Either you know that, but if you go over more GB RAM, your mobile or your computer will be fast, right? But you're not aware how come 4 GB RAM system works slow and 8 GB RAM system work fast, or more application you can install and run if you have 8 GB RAM compared to 4 GB. How the RAM is being utilized? What role RAM plays on your system? For example, this is your system, Windows system, right? You have 20 application installed. You can see this storage means disk, your hard drive, SSD is a storage, right? Means all the data will be stored on the hard drive or SSD, whatever storage you have, right? So, you know, whenever you shut down your system, RAM usage will be 0. RAM usage will be 0. And all your data applications are actually stored on the storage, that means disk. Once you turn on your system, any application you launch, you understand, sometime whenever you turn on the system, for example, once you open the Google Chrome, for example, if your system is having a hard drive, right? Once you open the Google Chrome, it may take some time. Or once you turn on your system, immediately you can't open any application. It takes few moments to run any application and to make your system ready, to make it to be usable. Why? Because when you shut down a system, all the applications are being saved on the hard drive or storage. Once you turn it on, right? Once you open application, right? It actually stored on the RAM. Google Chrome you open, once you first time you open, it takes some time because it is retrieving the application from the hard drive, from your storage. So retrieval time is more because it actually stored on the hard drive. So once you open, so it takes few moments. Instead of that, if you have SSD, solid state drive, which is coming now latest laptop, SSD 100 times faster. The laptop which are coming with SSD takes less retrieval time. Now, if you open the Google Chrome which having SSD, it will open faster than hard drive. But still, it will take few moments to launch. But once you already launch, whatever you work you do, it will be very fast. Because once you shut down the application, it will be stored on the storage. Once you launch, open the application, it will store temporarily on the RAM. That is the reason RAM is also called as runtime memory. Because while application is running, whatever activity you are doing, whatever data or anything you stored, it will be actually stored on the RAM. Once you close the application, then the data will be stored on the storage. More the application you open, more it will hold on the RAM, because while application is running, for example, you have one application which have 300 MB of size. One application you downloaded which have 300 MB of size. Get it, mean? Once you launch that application, it will hold on the RAM, then it will take 300 MB of RAM to hold the application. Get in mind? So now you see, now you must be aware that previously when we have mobile, 2 GB RAM, 1 GB RAM, we used to use them. That time application size was small, less, because those applications had less functionality that time, and size was also less. We have 2 GB, 1 GB, 2 GB. Now application which are latest coming will have more functionality and their size is also big. So if application size is more, once you launch that application, it will take more space on the RAM, means more RAM utilization. Yes or no? Once you install any application, if size is more, you should understand application does not take only hard disk, only storage. While it will run, it will occupy that much RAM also. Yes or no? So if you, for example, if you have 4 GB of RAM, you want run application 300 GB, 300 MB, it will work fine. Some other application also, you run some other application, if it reach around 4 GB, your system will become hang or may start working slow. If you open more and more application, it may go in the hang state and sometimes it get restart automatically. Yes or no? Because someone who has that much of capacity, right? If you put more load, more load, more load. Yes or no? So that is the reason if you want to install such application which have higher size, which is running all the time, should have more RAM. That's the reason nowadays, oh, we want 8 GB RAM, we want 12 GB RAM, we want 16 GB RAM, because I'm running some gaming applications. Gaming applications have a lot of functionality and more size, then require more GB of RAM. Understand? So RAM is runtime memory. If your system is running slow, then you can check it out what application is running. So you can turn off those applications, close those applications, because in the application there are multiple ways. So one is you start the application manually, or many of the applications are set to start automatically as a service. In mobile, you do not see service name, but when you select automatic start, that means it started as a service. So when you turn on your mobile, those applications will launch automatically. Similarly, on your system also, there are many applications which will turn on automatically as a service. You not see, there are many, for example, your audio driver, video driver, right? There are many other services. You want to take the remote access, remote RDP services will start automatically. Do you think that once you turn on your mobile, system, if you want to have a video call, do you need to turn on camera? No, right? Do you need to turn on mic? No, right? It gets started automatically. Those are also application, but they have set to start automatically. Apart from that, there's some other software which you install and customize, but they have set to start automatically. For example, WhatsApp, your Facebook Messenger, your Facebook application. Nowadays, more and more applications are coming which are running on the background automatically. So we have many such software installed which run on the background. That means those are running, means occupying the RAM. Yes or no? So you can set on if your desktop is running slow, right? Maybe one of the reason in memory utilization, right? There is a resource, there is an option called a task manager. If you are aware, we call as task manager. On taskbar, you mean below of your, you can right click and option task manager. You open the task manager and see your memory utilization, CPU utilization, and disk utilization. Click on memory utilization and check which application is eating more memory. If any unnecessarily application which is running that you don't use right now and using more memory, you can right now and end task. Once you do the end task, the application will get closed. Because the many of the applications running on the background, we can't see on the desktop, but those are actually running. We can see it using the task manager. You can right click and kill the process. That means you turn off that application and release the RAM. Understand? You understand the use of RAM? So so let me tell about the difference between your server hardware and your desktop. Your desktop or laptop has been designed for normal personal use. It has less RAM, 4 GB, 8 GB, 16 GB, 32 GB maximum, right? But in the servers, we deploy, for example, Facebook application deploy on the server. Any corporate application which required to access by outside user, many users, though, and it required to run 24/7. We use server. Yes or no? Server have more application. Server applications have more functionality as well as hardware capability is also more. This hardware of server on which we deploy a server, it is not same as your desktop. Same means having higher capability, higher capacity, and some more functions which require it to run 24/7. And of course, in server we deploy applications which have the higher size and should run all the time. That is the reason in server you need more memory. Get it going? And as soon as you require, you add more resources, add more data, or do some other activities, data will be stored. And once the application will run, the data is available in the RAM. Yes or no? So RAM size will be more and more. As soon as you work more in the application, store more data, more and more memory utilization. Yes or no? Understand? So, so that is the reason. That is the reason in the server will have more memory. More, for example, in our server we have around 280 GB of memory. 280 GB of memory. You can see your typical laptop having 4 GB memory, RAM. Our server we have 280 GB of RAM. You can divide by 4. 28 means 70 laptop. 4 GB RAM के 70 laptop के बराबर it has capacity equal to 70 laptop, right? We cannot increase this much in a laptop because laptop has been designed for personal use, while server has been designed for enterprise, for application deployment. That's the capability to increase more and more. That is the difference between the hardware server hardware and your workstation hardware. Understand the use of RAM? Do you understand what purpose we are increasing the RAM? Yes or no? Now, what is the use of CPU? Processor. Generally, the processor which are coming on your desktop laptop, it has 4 core, 2 core, dual core, or quad core. Yes or no? More the core, more the system will be fast processor. CPU, the processor. CPU, central processing unit, right? And short we call it processor. Processor means which does the task, which perform the activities. You want to copy and paste, okay? It's a task, right? You want to transfer the data, it's a task. Yes or no? You want to access the website, the browser is doing task, right? Whenever you perform any task, it is performed by the processor. Copy, paste, forwarding, receiving, right? These are tasks. Yes or no? So any of the application performing many tasks will use more CPU. Yes or no? Understand? So, for example, in your SIEM, you have SIEM console, right? If more and more the user will log in and search, more and more searches will do, means again a task, more and more CPU utilization. Yes or no? More and more user will log in and create some resource dashboard, report. This will schedule the report. Yes or no? Resources they will create. Now it will run on the RAM. More and more RAM utilization. That's the reason whenever we deploy any corporate application, it suggests what is the minimum RAM required to run the application, what is the minimum CPU cores required. Based on the size of the application, that much RAM, as well as based on the usage in future. More the usage, more the RAM, more the CPU. You understand? Use of RAM and CPU. And your storage, it depends on how long you want to hold the data or how much data you want to hold based on that. Sometime when your storage is full, that time also system will be unstable. So it will not be able to hold any data, right? Get in mind, if you hold more data on the RAM, but you don't have storage, yes or no, to hold, what will happen about the data? So system will go hang. So there are 3 reasons. Majority of the reason is RAM and CPU. When you see system is slow, 10:05 ho gaya. Last 2 minutes. When you see your system is slow, right? Either memory utilization is high or CPU utilization high. In some cases, if memory utilization 100%, 90%, that hard disk utilization, that time also you see the system is slow, right? So whenever system is slow, mostly we refer CPU and memory. So we refer what task is eating more and more CPU, more memory. If anything we have configured more EPU, more memory, we can kill those tasks, or we can disable those applications which are eating more memory. Understand? Now you'll be able to understand how much RAM you require in the system, how much CPU required. Clear? Clear to everyone?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Okay, great. So we'll wind up for the day. We'll connect tomorrow at the same time. Okay, 8 o'clock. Thank you. Bye-bye.
Okay, sir. Thank you.
Thank you, sir.
Sir, same
Thank you,
link or
thank you.
it will
Bye.
become different link?
What?
tomorrow?
Huh?
Same, will join same link or different
Same link.
link?
Now every day same links, right? And those links are
Oh.
unique for you. Means you
Okay,
should not
okay.
share anyone with the group or somewhere. I think someone has shared the group. But if you share someone, he will join, but you will not be able to join further. whoever joined first, because it has been configured to join from one device only. If one device already joined, if somebody else will join, you will not be able to join. So be careful, do not share with anyone, even in the group also. Links are unique.
It will start from 8 o'clock or 8:15, sir?
I will try to see. 15 minutes is buffer time. Idle time is 8 o'clock. You will be ready for 8 o'clock. Sometime for some maybe some traffic or something, I may get late, so I may ping you in that case in the group. 15 minutes is buffer time actually. I will try to start by 8 o'clock tomorrow, but 15 minutes is buffer time.
Okay, sir. Thank you.
Sir, 8:15 is fine for us, sir. 8:15 or 8 a.m. But my office login is 10 a.m. sir.
10 a.m. SAR will close tomorrow morning. I was in flow. I did not see the time actually.
Okay, sir.
I was in flow. I missed to see the time.
Okay, okay, sir.